You've watched 33 episodes of this series. Then the interview happens. They ask you to explain bias variance out loud in 60 seconds. Most candidates freeze or recite a textbook definition that says nothing. Hi, I am Mahaz, an AI engineer. Last episode, opening the black box with SHAP and Lime. Today, the interview questions that actually get asked and the answers that actually land. Episode 34. Top machine learning interview questions answered. Every answer in this episode follows the same three-part structure. 1. The one-sentence definition. Say it clean, say it fast. 2. The intuition. Why does this actually happen? 3. A concrete example. Interviewers remember examples, not definitions. Definition, intuition, example. Every single time. Let's go through 7 of the most asked questions in ML interviews. Question 1. Explain the bias-variance trade-off. Definition. Bias is error from overly simple assumptions. Variance is error from being too sensitive to training data. Intuition. A straight line can't capture a curve. That's high bias, underfitting. A model that memorizes every training point, including noise, has high variance, overfitting. Example. Linear regression on curved data underfits. A depth 20 decision tree on the same data overfits. The goal is the sweet spot in between, where test error is lowest. Question 2. How do you detect and fix overfitting? Detect it with a learning curve, training accuracy high, validation accuracy far lower. Underfitting looks different. Both training and validation accuracy are low together. Fixes for overfitting. More data, regularization, a simpler model, dropout, early stopping. Fixes for underfitting. A more expressive model, more features, less regularization. Always diagnose with a learning curve before picking a fix. Question 3. L1 versus L2 regularization. What's the difference? Both add a penalty on large coefficients to the loss function. L1, or lasso, uses the absolute value of coefficients. It can shrink some to exactly 0. L2, or ridge, uses squared coefficients. It shrinks everything smoothly, rarely to 0. Use L1 for automatic feature selection. Use L2 for stability with correlated features. ElasticNet combines both when you're not sure which one you need. Question 4. Precision versus recall. When do you optimize for each? Precision. Of everything you predicted positive, how much was actually positive? Recall. Of everything that was actually positive, how much did you catch? Optimize for precision when false positives are expensive, like flagging a legitimate transaction as fraud. Optimize for recall when false negatives are expensive, like missing a cancer diagnosis. F1 score balances both when neither error type clearly dominates. Question 5. Bagging versus boosting. Why does random forest beat a single tree? Bagging trains many models in parallel on random subsets, then averages their predictions. This reduces variance. Random forest is bagging applied to decision trees. Boosting trains models sequentially, each one fixing the previous model's mistakes. This reduces bias. That's how gradient boosting and XGBoost win competitions. One sentence. Bagging fights overfitting, boosting fights underfitting. Question 6. Why isn't a single train test split enough? A single split gives you one lucky or unlucky score depending on which rows landed where. K-fold cross-validation splits the data K times and averages the results. Always report a mean and a standard deviation across folds, not one number. Question 7. How do you handle an imbalanced dataset? First, stop trusting accuracy. 99% accuracy on a 1% fraud dataset means nothing. Use precision, recall, and the confusion matrix instead. Fix it with class weights or oversampling the minority class with SMOT. Never oversample before splitting into train and test. That leaks information. Common interview traps that make strong candidates look weak. Reciting a memorized definition with zero intuition behind it. Not asking a clarifying question when the problem is ambiguous. Jumping straight to a complex model without mentioning a simple baseline first. Forgetting to mention how you'd evaluate the model, not just build it. Going silent instead of thinking out loud. Interviewers want to hear your reasoning. If this helped, subscribe. Our first capstone project is next. Quick recap. Bias-Variance. Underfitting versus overfitting. Find the middle. Regularization. L1 zeroes out features. L2 shrinks them smoothly. Precision versus recall. Choose based on which error costs more.
Bagging fights overfitting, boosting fights underfitting.
Cross-validation beats a single split. Always.
Episode 35. Our first capstone project, an end-to-end regression pipeline.
Real house price data. Cleaning, feature engineering, model selection, evaluation, start to finish. Subscribe so you do not miss it.
Challenge task. Write your own 60-second answer to explain bias variance.
Include one concrete example and mention how you diagnose it with a learning curve. Record yourself saying it out loud and time it. Solution outline in the repo.
Post your written answer in the comments. I'll give feedback.
An interviewer isn't grading your memory. They're grading how you think.
Definition. Intuition. Example. That structure alone will carry you through most ML interviews.
7 questions down. Many more exist, but the pattern is now yours.
Our first capstone project builds all of this into one real pipeline. Episode 35, Capstone Project 1, Regression, drops next.
Subscribe. Which ML interview question trips you up the most? Tell me below. See you in the next one.